Hi everyone. In today's lesson, we're going to kind of build on this idea of analyzing motion graphs. But this time we're going to do a little more manipulation of a physical object. So in today's lesson, we're going to kind of do it on the computer. And in our next lesson, when I'm there, we'll use some digital tools like our actual motion detectors. But today we'll kind of get some practice doing it on the computer. All right, so first things first, make sure that you guys open up this link here. So again, you can open it up on your computer. That's kind of the preference, so work a little bit better there. Obviously, if you don't have it, you can work with a partner, or you can just scan this QR code. Just make sure if you are using your phone that you are staying on task. All right. All right, so when you go ahead and open up that link, you'll get to a page that looks like this. You click on that little play button, you get this little pop-up. We're just going to click the first option here where it says run CheapJ, I guess chirp, whatever. Just that first option. It'll take a little bit of time to kind of load up. And then you'll get to a page that looks like this. For the first minute or so, if you click on this person, you'll notice that some of these lines below begin to change. All right. A couple other things to notice. Below this person, there is, kind of like, I don't know, not a meter stick, but you have some measurements. What's different about this versus a meter stick is that the 0 meter mark is right in the middle. If we go to the right, our distance increases. Right, all the way to 10 meters. If we go to the left, however, you'll notice that we actually go into the negative numbers. Now, when we're talking about distance, right, your direction is relative. Right, when you're driving on the road, all right, doesn't matter where you are, you're pretty much typically always thinking about you're driving in the positive direction. You're driving forwards. However, if you saw someone on the opposite side of the road, right, and they're going the opposite direction of you, you wouldn't think anything about it, right? To them, they're also moving in the positive direction, even though they're opposite to you. However, if you notice that they were on the same lane as you and they were driving towards you, right, then you'd have some red flags going up, right? We would think that they're moving in the negative direction because you're going positive, they're going negative. Obviously, there's going to be a collision. So, direction is relative. What is forward to you may be backwards for someone. All right, so we're always just thinking about your perspective. What's positive? What's negative? All right. Another thing you can do on the simulation too is try dragging the position meter around. See what that does. Another thing you do is try messing around with the velocity one. Right? What happens when you do it in the positive direction or the negative direction? How's that changing their velocity? And how's that changing their direction? You can also try doing the same thing with the acceleration one, right? How's that different than the velocity? All right, so after a few minutes of kind of playing around with that, we are going to click on the second tab. So there's two tabs in this, right? You have your introduction tab, and we also have this charts tab. Right? So after kind of playing around on the introduction, we're going to go ahead and click on the charts. Now, you notice it's pretty similar, although instead of having those scales at the bottom, now we have some graphs. We have one for velocity, we have one for position, we have one for acceleration. Now in today's lesson, we're really only focusing on their change in position, also known as change in distance, and their change in velocity. So we can actually get rid of this acceleration one just to reduce some of the clutter. Over on the right-hand side, you'll see we kind of have these red minus signs, or to minimize it. So we're going to click on this bottom one for acceleration, this red minus sign. This will make my graphs a little bit easier to see and just have less clutter here. Now, we will notice when you start moving your moving man around, we start to generate some graphs, right? See if you can notice what's happening when you move your guy around. What does that do to the graphs? What does that do to the man? Now, alternatively, one thing you can do too, right? If you press this clear button at the bottom, right, that's going to kind of reset. Pause and reset. Bring my guy back to 0. One thing you can do is over here on the left side, right, you have this blue arrow for the position. Also have this red arrow for the velocity. So one thing I can do when I press play is if I move one of these arrows, it's going to help me kind of generate some specific graphs. Now, the goal in this activity, just going to reset everything, is to do some graph matching. For problem number 1, we're given a position time graph that looks like this. All right. So we have a position time graph where our person is not starting at 0, right? 0 would be down here, right? They're starting at some position above 0. Now you kind of notice it doesn't look very much like their position's changing. Our goal here is try to recreate this type of graph. So I notice that the person's not starting at 0 in that graph. They're starting somewhere above 0, right? It doesn't give a specific number. It doesn't really matter. I'm just going to choose some position above 0. Not below 0, but above 0. My goal is to try and generate that exact shape of that graph. Go ahead and pause it. That looks pretty good. Now what I can do is I can look at, okay, if I got a position time graph that looks like that, what does the velocity time graph look like? Now I notice that my velocity time graph is actually going to be just 0. And that should make sense because my person's not moving. So for each of these, we're going to look at what is happening, right? How can I describe the person's motion? I can say a lot of things about it. I'm just going to say the person stays still, or a person is not moving, or a person's position stays constant. All right? Because when I look at the position graph and I look at what I did to the person to make them match that graph, I notice that the position, or the pattern in our position time graph, is horizontal. Which also means that if the person staying still, that their velocity is also 0. And we think back to our formula for velocity, right? Our velocity was distance divided by time. In this case, if their change in distance was just 0, right, they never moved, right, then 0 divided by anything is just going to be 0. Hence, we get a horizontal line along 0 for velocity. Still horizontal. Remember, horizontal just means there's no change in the y. Now, finally, we get to a motion map. Now, a motion map, I'm going to show you some pictures here. Okay, so a motion map is going to be, if you think of setting up a camera, and then taking one picture like every second. Right? If you have a moving object, you're going to be able to see where that object is at each second. So if we take this picture as an example, all right, one camera set up in one position, taking a shot every second to see where that person is. You notice this person is pretty evenly spaced out. One thing that suggests is that the person is moving with a constant velocity, right? Every second, they're moving the same distance, right? That means they're not speeding up, not slowing down, they're staying still. However, when we looked at our moving man to create a horizontal position time graph, at every second, they were just in the same exact position. So let's create a motion map of that. We're going to see that this person, right, at 0 seconds was right here. At 1 second, they were still there. At 2 seconds, they were still there. At 3 seconds, they were still there, right? That's not really changing. All right, next, for question 2. Once again, given a position time graph, we're going to try to match this graph and then see what we get for a velocity time graph. A couple things to notice. One, the position that the person's starting at, right, at 0 seconds, this would be 0 seconds down here. The person is not starting at a position of 0. Rather, they're starting somewhere above 0 and then moving beyond 0. So you think about what you need to do to create a graph that looks like that. Clear this. Set you up here. All right. So to create a graph that looks like that, play. All right. Now, it's not perfect, but I can see from about 2 to 4 seconds, I have a pretty good linear line. Right? That kind of looks like what I have in the graph. If I look at my velocity, the red line, from 2 to 4 seconds, I mean, it's a little bit bumpy, but it looks pretty horizontal. Now, I can try a different method here. Go ahead and test the theory. All right, I'm going to just move this red arrow here. Right. Notice when I set the red arrow up, right, it's just going to move automatically. And that gives us a much cleaner linear line rather than me moving the person by hand. All right. All right, notice here, right, you get a much clearer velocity time graph. Interestingly, it's the same pattern as what I saw in the graph above. However, this time, it's not at 0. So a couple things I can do. I can describe. So person. So when I'm thinking of a moving object, a few ways I can describe object's motion. It's either speeding up, slowing down, or moving with constant velocity. All right. So for our position time graph, we look at the line. It's linear. And for velocity, it's still horizontal because our object was not getting faster. It was not getting slower. It was staying constant. Now, if I go back to that one image of the person on the bike, all right, think about my movie man. If I pause this every single second to kind of see where they were, right, I would get probably an image that looked kind of like this, right? Every second, they moved, and every second, they're moving the same distance. So we're getting a line that looks kind of like this. Right, so at 0 seconds, my person was here, right? Because I didn't start at 0. At 1 second, my person's here. At 2 seconds, my person's here. At 3 seconds, my person's here. Now, this would look a little bit different if the person was speeding up. Obviously, it would look a little bit different if the person was slowing down. All right. What we have is we have a few more of these, 3, 4, and 5. Obviously, they get a little more complex here. For each of these, you start by matching the position time graph. You'll notice in this case, right, again, it's not starting at a position of 0. It's starting somewhere above 0. And notice here, it's actually going down. So think about what can you do with that moving man to get this line to go down? What's that going to look like in your velocity time graph, right? Then describe what's the person doing and what are the patterns you got and your motion map. Notice here, we have 2 different things going on. So this kind of a dotted line here is kind of indicating that you have one type of motion to start with and this second type of motion afterwards. Same thing here. So for all 3 of these, right, match the position time graph, sketch out what you're getting on the velocity time graph, describe what is the person physically doing. All right, what is our relationship between position and time? What's the relationship on the velocity time graph? What will this look like on a motion map? All right, and do that for all 3 of these on the second page.